Welcome, fellow JavaScript haters. I'm going to talk to you about what you can do if you hate JavaScript, if you don't want to use it anymore. And I recommend heeding this instruction right here. I've been trying to speed up videos on my YouTube app on my phone, and it hasn't been working, but hopefully it works for you. Watch this video sped up. Trust me. In this video, we'll cover what JavaScript is, just a basic introduction of how it actually works and how it came about, because this is stuff I recently started to understand, even though I've been using JavaScript for a while. How did we get here? Why do people hate it? Why, how we can actually not use it, and then some of the best ways that I found of using no JavaScript to still develop amazing applications for the web, and then the problems that we still have with these approaches and kind of what the future looks like. So let's just get started here. What is JavaScript? Now, JavaScript is actually the only native way of manipulating things in the DOM, on the client side in the browser. So you think about, you request Amazon.com and you scroll and you add something to your cart. There's JavaScript running on your browser that actually sets everything up for you. And that can't be done natively with any other language. It's only JavaScript where you can actually interact with the DOM, okay? And this is, we'll talk about this later, but, and by the way, DOM is the document object model, which is basically like the markup and moving things around. And because of the ubiquity where it's used on every single browser, every single person, basically up to this point that's developed for the web has had to use JavaScript at one point or another, they're like, why don't we just use this in other places so that we can not have to context switch and use the same language? So there's stuff like Node.js or recently Deno and Bun, where you can run JavaScript on the server to feed stuff into your application or run stuff on the server, you know, parallel to your application, or even stuff separate from your main web app. So whatever you need to do on the server you can with JavaScript, and there's even more libraries for it. So it's extremely widespread. But it also has a lot of quirks that kind of make people hate it. So we'll talk about that in a second. But here's how we got to JavaScript. So JavaScript was built by this guy, Brendan Eich, at Netscape back in the early browser days. And I highly recommend that you watch this video on the Lex Friedman Experience, or Lex Friedman podcast. It's an interview with Brendan Eich, and he talks about JavaScript for, I don't know, about the first half of the episode. And it's really good. And there, in the early days of the browsers, there was Netscape, there was also Internet Explorer, and they were kind of competing. And obviously Microsoft had a huge share of the market because they owned a lot of the operating systems. And Netscape was trying to compete, and they saw a need for a way to interact, to make the browser web pages basically dynamic, so that if you click, you know, something in the menu bar, it could open a new page without, you know, navigating somewhere else, right? You could do links, but you couldn't do like native, like, you know, pop-ups or whatever. Like, so much of what we use on the web is run by JavaScript, and there was no way to do that. It was just static HTML and CSS being served on websites. And so they saw a need for that, and there wasn't a standard way of doing that, so they had to put something together, and they had to do it quickly because they saw that Microsoft was coming, and they thought that if they could set up this system and get it working the way they like it, they would have some sort of advantage. So what they did is they told Brendan, look, we need this done, and we need this done yesterday. And so he built it in 10 days. At least the first version of JavaScript was built in 10 days. It wasn't called JavaScript, it was called Mocha. But they were modeling it after Java. Yeah, you've probably heard of Java, and I saw this funny YouTube comment that Java is to JavaScript what car is to carpet. There's no fucking relation, you know, they sound the same. But it was sort of modeled after Java, although, and that's kind of where the name comes from, but in every other way, it's basically completely different. And so, let's get on to why we hate JavaScript, why most people hate JavaScript. In fact, if you've ever read 0 to 1 by Peter Thiel, there's a piece where he asks, you know, if you, what's one thing you would say that most people would disagree with you about, you know, because it's those insights that can build really big companies. And I would say saying you hate JavaScript is actually the most common thing you could say. If you say you love JavaScript, then you're in the minority. So basically, first of all, it was built in 10 days, and this results, I mean, it was kind of a rush job. You know, if you look at something like Golang or C or whatever, these languages are widely loved and also widely used because the people spent a lot of time on them, making them really good, and they weren't just iterated over time. So because of the weird way, you know, JavaScript was built, and maybe potentially due to some sleep deprivation, Brendan, you know, at a certain point, some developers were like, hey, can we just make it so that 2, the number 2, is equal to a string of 2? And so that is basically how it works today. If you compare the number 2 to a string of 2, that is actually true. That's equal. And so we have this unique triple equal sign operand, which basically is the actual equality operator. So that's one of the weird quirks. And then there's a ton of other weird quirks where you're just like, why does it work this way? And you know, it's just not beautiful to use, you know, like some other languages. Now, another big thing about JavaScript is it was designed as a dynamically typed language, and it still is a dynamically typed language. And if you don't know what that means, basically in a statically typed language, so let's just come over to some TypeScript here. So we'll talk about TypeScript in a minute, but if we're using TypeScript, I can say, or actually let's do let test a variable called test, and we're going to say this is a string, and we'll assign it to the value of test, okay? And then we'll do now we're going to try to assign test to the number 23. And if I hover over this error, it's going to say type number is not assignable to type string, because we're trying to assign a number to a string. And this is very good. This means we're going to catch errors ahead of time. But if I were to create a new file here, a JavaScript file, and we say let test equal test, there's no type annotations because this is normal JavaScript. Now we can assign, all right, well, this is still TypeScript, basically looking at it, but we would be able to assign test to the number 23, and it wouldn't throw a fit about that at all. And so you end up with this weird behavior, which is in part intentional, because this just makes it faster to build stuff and to throw stuff at the wall. And you have to remember that JavaScript was designed in 10 days in you know, the early days of the browser wars, where you had to get mass adoption. This language wasn't prioritizing, you know, ease of use or the beauty of the language. It was focused on how do we get a lot of people using it. And so they were like, how can we make this more approachable? Let's just make it dynamic. And this results in problems when your app starts to scale, because it gets very hard to eliminate errors if you're assigning a number to something that should be a string and there's no errors that telling you that you shouldn't be doing that. You're going to have a really weird error, and they're going to show up all over the place. And the only way to get rid of these errors is just by basically brute force testing. Just, you know, either setting up some testing environment or just fucking going in there yourself and clicking around and trying a bunch of stuff to make sure that it works perfectly. And this is interesting because most modern languages, you know, you think about like these very popular languages like Go, Rust, I don't know about Erlang, but most of these modern popular languages are statically typed. So you actually have to assign a type to your variable, and then if you try to reassign it to the wrong type of variable, or if you do something that's fucked up, it's not going to let you do that. It's going to catch that error, and that's built into the language, which makes it basically statically typed languages are easier to work with in larger code bases. And of course, TypeScript can help with this, but it's not perfect. You know, a lot of kind of apps nowadays, like Dino and also like Svelte or Next, these frameworks for building on the web, they'll have TypeScript included. Okay, and so you don't really have to do a lot of setup, but there are just things that kind of bug you. And I was having an error the other day where, oh, let's see, yeah, so I found it. So we're importing this database type from Supabase. So they generate a type for your database so you can use this in your code. But this wasn't working. You know, even though the code was working perfectly, TypeScript was still throwing a fit because it didn't understand that what I was doing worked. And sure, maybe that's a skill issue, but you know, at the end of the day, I had to, well, truthfully, got AI to define this type that will, you know, let TypeScript not throw an error. But I'm just like, stupid fucking TypeScript. You know, we already have this type. It should just work. And you'll run into these issues, especially if you use Next.js with ESLint. ESLint is particularly tough in Next, where it'll say you can't use an any type for this. So you could do something like const test any, and then this can be any type. So you can annotate things like that. But if you did that in Next.js with ESLint, you know, most of the time you go to deploy your app, it's not even going to deploy. It's going to be like, hey, you can't use any here. It's going to stop the whole deployment. You can't deploy changes, and you basically have to go back and refactor your codes to make TypeScript happy. Even though it works, you have to go back and make TypeScript happy. And this is just kind of annoying. Kind of the annoying part of using TypeScript is you'll have something that works, and TypeScript won't be happy about it, and so you have to come back and you have to fix things. And of course, this is kind of just a thing in a lot of, you know, statically typed languages. But with TypeScript not being, you know, kind of native JavaScript, you just end up with more scenarios where this happens. And there's stuff that isn't supported in TypeScript, you know, that has to be done eventually for things to work perfectly. So it's just not perfect. And you know, on top of that, I'm using Svelte now to build an app, and we're sending data to the front end from our server. So we have our server action, and this is it. So we're returning this data, and then on this page, we have our page data object, which gives us this data. But it just kind of gets confusing where you're trying to like access these types, but you're not exactly sure how they're nested because there's a little bit of convolution. And so this is another problem that happens when you're mixing things from the front end to the back end. It just kind of gets confusing and difficult. So that's the thing on types. JavaScript is also a JIT language. Young JIT. So that means just-in-time compilation. So when you're running JavaScript on Chrome, when you load, you know, a web page that uses JavaScript, it's basically loading in that JavaScript from the server, and then as soon as it gets it, Chrome is running that JavaScript, and it's just plain JavaScript. It has to be compiled into machine code in order to actually be executed on your machine. And this is all done as soon as it's loaded on the machine, which basically is not as fast as a compiled language. There's the V8 engine by Chrome or Google that compiles JavaScript quite quickly. You know, JavaScript's pretty fast nowadays. But when you compile things, also you sometimes find errors, and I mean, compiled languages are always going to be faster than like just-in-time languages, and so you just don't get that benefit when you're using JavaScript. We also have the Lindy effect, where basically if something's been around for a long time, you can expect it to be around for much longer, which basically is to say that there's no real end in sight for JavaScript. It's been around on browsers for so long, and it's not really a problem. You know, JavaScript's fine. Obviously it has problems, but it's fine, and so it'll probably be around for a long time. And I think a lot of us are just staring down the barrel of, you know, another 25 years of using JavaScript, and we're like, yo, that's a long time. And finally, it's just not the most kind of graceful language to use. You know, there's a lot more kind of enjoyable languages out there to use, and the only problem is JavaScript is the only thing that can manipulate the DOM directly, and we're basically just relegated to using that. You know, it's like if you're a millionaire and you go to work at McDonald's, you're like, yeah, man, it's gonna be fun because I can go, you know, talk to these people and I can see what it's like. But if you're broke and you have to go work at McDonald's, it's an entirely other emotion. So if you're forced into something, it's never going to be as fun as if you choose to do something, right? So kind of the, you know, the sentiment has been we're forced to using it, or are we? what if we didn't use it? And this is actually possible because if we look at something like, most modern frameworks, or not most, but a lot of modern frameworks, we have things like Ruby on Rails, which is actually written in Ruby. I was curious how this works. Maybe you're curious because it's written in Ruby, not JavaScript, and JavaScript's all that runs on the browser. So how does this work? We also have Django or Flask, which is Python. We have Vapor, which is for writing in Swift, which is Apple's language. We have the .NET framework, which is C#. You kind of get the idea. There's actually a lot of different ways to build for the web without using JavaScript. So let's talk about it. Technically, the reason for this is because all we have to do is return HTML to the front end. So if you think about the days of the web before JavaScript, they were using Java or C or whatever they were using on the server. When someone made a request to get that page, they would just send back pure HTML. And that's essentially how the web still works today for a lot of websites. So not every project needs to have complex processes running on the front end. If you think about a basic blog, just static pages with maybe like a search bar, that doesn't have to be super complicated. It can literally just be pure static HTML, and you can run the search bar based on like a query parameter. So if someone suggests or requests, myblog.com query equals cars, then we would just send them back a page of blogs filtered to those that contain car in them. So that's basically all you have to do. You don't actually need this complex JavaScript for a lot of projects, and even when you do, there are solutions. But this is kind of how things started to be built, and I'm not exactly sure why. I think React started to get popular. They saw that an easy way to add a bunch of reactivity on the front end was to just dump JavaScript into the front end. So if you want to open a menu or whatever, you just click and then it opens the menu. But it doesn't actually have to be this way, and I think a lot of people are starting to realize this with kind of things like what we'll talk about in a minute, but also just the bloat of React and how big a project is. So here are the best non-JavaScript ways of developing for the web. And I'm actually, there's this great survey from Stack Overflow about the most popular web technologies. And we have, if you haven't seen this, basically there's admired. So this blue on the left is how much people want to use this, how many, what percentage of people who haven't used it want to use it. And so it's ordered based on that. And then on the right, we have desired, which means people who have used it, what percent of them want to keep using it in the future, okay? And you'll notice something interesting here, where the most popular, or the most desired, I mixed it up. It's admired is people who used it and want to keep using it. Desired is the opposite. So the most admired language or framework and technology for building on the web is this thing called Phoenix. Okay? Phoenix. That's not what we want. Phoenix framework. Interesting. What is this? This doesn't look like JavaScript. I'm sorry if you know what Phoenix is, because I'm playing this out. This is actually Elixir. This is a language called Elixir, which is based on Erlang, and this is how you can build websites without JavaScript, and it's actually the most admired language or framework for building on the web. Also up here we have ASP.NET Core, which is C#. We have Svelte, which is JavaScript. We have HTMX, which is basically bring your own backend, do whatever you want on the backend. And then we have Astro, which is also JavaScript, or I'm not an expert on Astro, but there's a lot of different ways to build things that are more admired or more like enjoyable to use than these JavaScript frameworks. So if you looked at React, Node, Next, Vue, Angular, Express, jQuery. Wow, jQuery. No one likes jQuery, dude. That's crazy. I mean, look at all these things. There's just like so much stuff on here that is JavaScript based that's people just don't like using. Especially Angular. That's the lowest one. Wow. So it stands to reason maybe these are decent ways to build on the web, and maybe these are ways to escape JavaScript, to use your own language that you actually like using, and still build amazing apps for the web. So we have basically these 4 options, and I'll also throw in Svelte because I think Svelte is, Svelte is interesting because if we look at one of these pages here, so this is Svelte, and it is JavaScript. On the server you're writing JavaScript or TypeScript, but this right here is not JavaScript at all. This is Svelte. This is purely Svelte. So if we have a variable called show create right here, we're using state so that we can dynamically update this, and it's set to false initially, and then we have this action or this function that can toggle this on or off. And when we click a button, this is a create card that'll allow us, it's a pop-up that allows us to create a new object. If this is true, then we're showing this, and then if this is set to false, then we're hiding this. And this is JavaScript in the back end, but I'm not writing JavaScript at all here. This is an abstraction, because what's actually happening here is when we set show create to true, Svelte in the back end has to go on the client side, they have to go to the DOM, they have to update the DOM, they have to pull out this new, HTML element, and then they have to insert it onto the DOM so that it actually shows up, and then they have to destroy that element when show create is marked to false. So this is also an abstraction, and I think Svelte does a relatively good job of abstracting that, but of course you're still writing it, on the server or a lot of the time on the client. So here are the options. So we have ASP.NET Core, which is C#, and truthfully, I don't know that much about this because I tried to look into it. It looks fairly complicated, and a lot of people are using Visual Studio as opposed to VS Code. And I like using Cursor. I'd rather use a language where I can use Cursor. It just seems a bit corporate-y and kind of underground, but it is, I guess, quite admired. So anyways, I'm not going to talk about that too much. If you want to learn about it, you can look it up. Then we have Howl. So Howl, I think, is kind of a term. I learned it today from this guy, Hammy Labs. And essentially what this is it stands for Hypermedia on Whatever You Like. And the beautiful thing about this is you can serve HTMX and Alpine on Go or Python or Rust or literally whatever language you want, as long as it is able to be used for networking. And then we also have Phoenix, and then we have WebAssembly. And so I'm just going to go through these 3 technologies. This video is already long as shit, but I'm just going to go through these 3 technologies so you can understand kind of what the options here are. So let's first start out with HTMX. So HTMX has had a lot of buzz recently, or in the last couple of years, and this is a way to build apps where you're primarily building from the back end, and you're not really doing much on the client at all. So what we're doing here is instead of having this kind of block where we go, if this variable is marked as true in our JavaScript, then show this element. Instead, what we're doing is in HTMX, we're adding an attribute to our HTML element that we ship directly to the browser. We're saying when this is clicked, we're going to swap out the parent div with whatever. And I haven't used HTMX, so I'm not exactly sure what the syntax is. But what we can do is we can say, all right, whenever someone clicks this button, make a request to the server, to this endpoint, and then we can return this div. So it would basically be like, if our button to activate this, if we had this button that said add new, if we go on click, then we would add a web address, which would be show create. But what we would do is request this from the backend, and then we would just send back this div exactly, and this would show what we need to on the client. So of course we have to add a network request in between those to show this item, but that simplifies everything incredibly, and you're not actually writing JavaScript. Of course, this is just a wrapper for JavaScript. When you include HTMX, they have methods for each of these that write JavaScript on the browser, and execute it for you. So in order to swap out an element, that requires JavaScript and dealing with the shadow DOM or the DOM, but you don't have to deal with that. This basically covers it for you. Now the other thing with HTMX is if we go to let's see, I'm trying to think of a website where we just have basic like interact. So okay, so this menu bar right here. So this menu bar requires client-side state, basically. Because in order to show this or not, we need a variable that tells this HTML, this div right here, whether to show or not. And with traditional HTMX, what you would do, is funny it's on their website, I'm sure they're using something like Alpine for this. What you would do is you would say, when someone clicks this button, this would be a button or a div, when someone clicks on this, then ship them this div, okay? So it might take 100 milliseconds or 200 milliseconds or however long it takes to go to the server and back, but that's how you would do it. You would basically be swapping out every single element using the server, which is a little bit expensive on the server. I mean, you know, if you're using like a compiled language that's way faster than Java or JavaScript, then, you know, maybe it's totally fine. But you can also bring in something like Alpine.js. So Alpine.js is something to kind of work with HTMX with. And essentially what you do here is it's like HTMX, but for the client. So what you can do here is you can assign things like show is, so you can say the class is open. If open is true, then it's going to be hidden. If not, then it's going to be false. And then we can set open or false, open to true or false based on button clicks. And this is all done client side. So same thing here as HTMX. This is just a wrapper for JavaScript. There's still JavaScript executing on the client, but you don't have to write it. You basically end up just writing these basic classes, and then this manages the client state. So for something like that menu bar that we were looking at here, or this menu button, this is probably using Alpine because it's just flipping a Boolean to true or false of whether or not to show this this menu. So that's what you would want to bring in to HTMX. And if you want to learn more about HTMX, I highly recommend this video. I just watched it. You Don't Need a Front-End Framework by Andrew, this guy. And it's interesting. He shows how this works. Basically, what you're doing here is you have a table of all these cars, and whenever someone like selects one of these filters, you can have HTMX send a request to your backend, and you'll just send them back all this HTML with the right cars that they should be looking at. And so what you end up with is all your HTML in your backend, and that in the first part he's talking about how to do it just with JavaScript, and then he introduces HTMX, and he's showing that basically you just return this pure HTML to the client and swap out the table that they're looking at. Whereas in React or something, you might have, you know, when that person loads the page, you would send the whole list of cars, and then whenever they engage a filter, you would just filter that list on the client, and then they would only see the result of the filter. But with this, you would filter things on the server and then send them back the pure HTML. So this is a different approach, but it also means that all of your code is going to be in the same place. It's going to be, you know, in this case it's PHP, but you could use, you know, Ruby or Rust or C or Swift or whatever you want. You could use that on the back end to, you know, take that request and then filter the response and send it back, and construct the response and send it back. And a lot of these things like Go with Temple or Python with what's it called, like Django, they have a language where you see this is a page.blade.php file, and you can see you get like normal, you know, tag closing and opening checking for HTML here. So it actually shows you the right kind of syntax. You don't just have to do like a template string, because what you would do typically is, if you think about just like writing, you know, pure kind of templates, is you would say return, and then you would do backticks, and then this just gets so fucked. You would do like div, and there's no like this now is a string. This is not HTML, at least to your editor, and so, god dang it, dude. So you have to like manually write. Yeah, you have to like manually write everything, and it's just like, it's just not, you know, a nice way of doing things. So the benefit with some of these HTMX templating languages like Go. So, you can use Go or Python, and then they have packages that can be added to make templating easier so that you can actually build an application. Now, there is a counter argument to this. Actually, I'll get into this in a moment. Then, we also have Phoenix with Elixir, and they're doing some pretty fucking incredible things with this. So I was also watching this video initially, but, sorry, Theo, you're annoying. Especially because I was watching on my phone, I couldn't speed it up. But essentially, with this, with Phoenix, this is built on Elixir, the programming language, but it does an amazing job of building dynamic websites. And the way they do this is really interesting. Instead of just having a back and forth request where someone just requests to the server, hey, can I get this page? And then the server sends it back. With Phoenix, with Live View, it opens up a constant connection. I don't know exactly how this works, but that server now has a connection to the client that remains open. And so you can store state on the server instead of having to manage state on the client and then have that reflect on the server and then, transfer that into your response. You can manage state on the server, keep everything, have your own environment on the server, and then just send back whatever makes sense. And so there's a lot of cool stuff here. And the interesting thing here is this starts to look like Svelte. Of course, it's on the server and you get to use Elixir, which is a nicer language to use than JavaScript. But you're opening these braces here and you can insert your dynamic data inside of the HTML template. And this is kind of the magic of Svelte, even though Svelte is an abstraction. This is that magic, but server side, where you control everything and where you get, kind of better, not separation of concerns, but kind of combination of concerns where everything is one place and you don't have to worry about, problems between different places. And so the interesting thing here about Phoenix and about Live View is instead of sending this whole template all at once, so when someone loads this page, we're going to send this whole template with whatever, the temperature and the thermostat mode are. We would send that all at first, but because they can open a connection directly to the client and keep that open, what you end up with is whenever like a change is made, you can just send a super simple JSON payload like this, where it knows exactly where to insert that into the DOM. And so it's handling a lot of this stuff for you, and it can surgically update the DOM without you having to, worry about that. It just kind of does it because of that live connection that's kept. And if you want to learn a bit more about this, I would recommend this video, Live View.js, the comprehensive guide. Also, I guess Theo's video isn't that bad, because he does a good job of explaining it much better than me. But yeah, overall, I think this is really interesting. If you're looking for an alternative to, Svelte or Next or these kind of JavaScript frameworks, I think that Phoenix with Live View hosting on something like fly.io, you could really get something cool here. And I think it's, kind of in the infancy stages. It's pretty new, but I do think that this will be a serious contender in the future, especially because it allows us to move away from writing everything in JavaScript and we can actually, start to use something more interesting like Elixir, and hopefully this kind of cascades into other languages that people seem to really like. I've only really used JavaScript and a tiny bit of Python, but I really want to, be able to use Go or Rust or Elixir or... Dude, I remember using Lua in Minecraft because they have this mod where you can get a turtle. It's called a turtle. It's like this computer that can get a mining pick and you can program it. I guess the fun is you have to program it to like do a certain mining excursion. So you can say, hey, go down this far and then, go up and down so I can walk down this pathway and then turn around and mine every single block. And you can do that with like, and that's Lua. Lua is a very popular scripting language, and it's not the most advanced. You wouldn't use it for, something like web development, but I do think there's a lot of beautiful, kind of fun and simple languages out there that would be more enjoyable and potentially more scalable than something like JavaScript. Okay, so finally, moving on, there's this thing called WebAssembly. So I don't know if you've heard of WebAssembly, but this was kind of a way... The thing that WebAssembly is it's actually like machine code. And what this does is it can run on your browser. And so if you ever load up like a game on your computer, like they had a demo where they were running, Doom or something on a browser. And this is actually possible because it's not actually running JavaScript. It's running this thing called WebAssembly, which is now native on most modern browsers. And what it does is it's a compilation target. So you can say take C or C++ or Rust or a lot of different languages, and you can compile them to WebAssembly, which means any of these languages can actually be run on the server, on the client. So that means you could theoretically write your entire app on, like Swift or C or Go or whatever language you want, and then you could just compile that down and have it run on the browser. But the problem with WebAssembly at the moment is there's no native way to interact with the DOM. So if you ever want to do a DOM manipulation where you're changing out some element, you have to interface with the JavaScript, and then that JavaScript has to do the thing for you. And so you end up, basically, it's just slower than normal JavaScript and more of a pain in the ass. And so there's no really reason to use WebAssembly at the moment. But I think in the future, this would be a really cool proposition where instead of having everything be JavaScript, everything is just this sandboxed kind of executable that can be run on any web page, and you can write in any language you want and then compile it down and it'll run in the browser natively. I think that's kind of the ultimate goal. But lastly, let's just cover the problems with these approaches. So first off, there's a lot of problems that Svelte and these modern frameworks solve for you. So something beautiful about Svelte is if we look at this page, what we're doing is we have an asynchronous function right here, which is fetching some data from the database. But in order to send that data to the front end, so when someone requests this page, this function will execute, and then we'll send that data to the front end so that we can render it on the client. But what we're doing here is we're not actually awaiting this promise. We're just sending the promise as a promise, and that means when this page loads, we can use await, and we can say wait for these credentials that we're loading in, and then when those are ready, actually render stuff out the way we want it. And that means that is extremely hard to do, okay? Because the problem is if you go to navigate between pages, okay, so let me just show you this. So if let's just add a timeout here let's do 2000 milliseconds. So whenever we navigate to this page, we're going to see a timeout of 2 seconds. But what we notice is we navigate to this page instantly, okay? As soon as we click on this page, the heading changes and we're on that page, and then it just takes a couple of seconds for that data to actually stream in. And that's beautiful. Now, if we keep this timeout, but we add an await step, now when we try to navigate to this page, all right, hang on. Okay, so now it's working. So we'll go back, and what's going to happen is we click on that page, and nothing happens for 2 seconds until we're navigated to this page, until the data is ready. So we click on this. Why is it not working? It's like caching or something. So I just clicked on it, and boom, now it's ready. So this is extremely useful. So to be able to do this, to be able to just route them wherever they want to go and then have the data stream in as it becomes ready is great. And we can't exactly do that just natively with HTMX or Phoenix or whatever. It's going to be a lot harder to do, and you're going to have to basically jerry-rig things to make them work. And this is just one example of one of the problems that these modern frameworks have solved. So as these frameworks using other languages become more popular, I'm sure these problems will get solved, but at the moment, you're going to have to be the one to solve them. Or your app's just going to feel slow or have this kind of problem that most apps don't. Then we also have client state. So if you think about something like hypermedia on whatever you like HTMX, every request is separate from every request, which means you can technically run this on a serverless deployment. So basically, if someone requests the home page, we just send them back the home page. It doesn't matter where they're coming from or what the server location is. We just send them back the same thing for the same type of request. Whereas if you're doing things on the client, you need some way to manage that state so that you can send them different stuff for different things. So you can basically only use cookies or the URL, like URL search params or the path. Yeah, I mean, with JavaScript, there's easier ways to do this, and so that's also a problem. Then it's also a bit server intensive. You know, like we were saying earlier, that menu on the HTMX website would have to be server rendered, which is why you would bring in something like Alpine.js. So you still need JavaScript on the front end to manipulate DOM elements for the time being. And then it's also hard to debug, because if you look at something like Alpine.js, I mean, this is not JavaScript. This is not Svelte. This is just like markup, and there's no like syntax highlighting, you know, or you're not going to have as good type checking or, you know, ability to find problems and debug as you would with some native language. And so it does get a little bit kind of, you know, hard to manage. Okay. And then, yeah, last thing, WebAssembly. I think WebAssembly is the most promising. It's badass, but at the moment there's no direct way to manipulate the DOM. And also, I mean, this is, a lot of this stuff is how kind of websites used to run. If we think about Ruby on Rails, this is an old framework, and they used to just swap out DOM elements, you know, using like stuff on the server, but we went away from it to manage more complex client state. And so for more complex apps, I think the JavaScript, you know, frameworks are the best way to go. But for simpler apps, I mean, this old kind of paradigm can be simpler. I've seen case studies where people say they cut down their code 70% in some cases, which is fucking crazy, because 70% code reduction means you're basically having fun coding again versus being in massive technical debt. So yeah, I mean, that's all I wanted to share on this topic. This is my longest video ever, and my voice is so tired. But I might make another video about just this part down, because I think, you know, these are really interesting. I don't think any of them are really quite... I think HTMX or Howl is really the closest that we'll get at the moment to just doing things, you know, completely framework agnostic, where you can use Go and Temple or Django and Python and whatever you want to do. But there are limitations there, and overall, you know, Svelte is still kind of goated. But in the future, I think these would be really cool, especially because JavaScript's been around for 25 years. I mean, there's been lots of newer, nicer to use languages, and I'd much rather, you know, have the flexibility to write, you know, it is fun to do the most trendy thing. Obviously, I'm using Svelte. You know, I'm not some convention guy that's gonna like, I'll let everyone else test it out. No, I'm gonna test it out, you know? Imagine if like, in, you know, the .com boom or whatever, Jeff Bezos was like, oh, everyone's using the internet, I'll just let them try it out, and then I'll, you know, jump on it in 10 years or something when it's popular. We wouldn't have Amazon, right? Obviously, it's good to be kind of on the cutting edge, and maybe there isn't a ton to gain, but I think there's a lot of benefits in simplifying your code, in simplifying the way things work, because faster iteration is becoming more popular, you know? So anyways, that's my entire video. Thanks for watching. I'll leave a link to a Discord server if you're into building stuff, especially businesses on the internet. You can click the video below, and love to see you there. But otherwise, thanks for watching.